Hello all. In this video, I'll be discussing about the problem number 88 of LeetCode, that is merge sorted array. So first let's understand the problem statement. You are given two integer arrays num1 and num2 sorted in non-decreasing order. Here the keyword is non-decreasing order. And two integers m and n. So this is the input along with the num1 and num2, where m and n represents the number of elements in num1 and num2 respectively. So basically there are m and n elements in num1 and num2 arrays. What you need to do is merge num1 and num2 into a single array sorted in non-decreasing order. So this needs to be the output. Now another thing that they have put as a constraint is that the result must be stored inside the array num1 only, and for accommodating this they have already stretched the length of num1 as m plus n. So in short, let's have a look at this problem something like in simpler terms. Okay. So the input that is expected is num1 and num2's arrays having m number of integers in num1 and n number of integers in num2. The output needs to be that the numbers must be first of all merged and they must be stored in num1 in non-decreasing order. So let's look at the solution now. The first and the foremost solution, and easier one also, that comes to my mind is, why not copy the remaining elements of num2 into num1 and then sort that array? So something like this can be the scenario that first of all 1, 2, 3 is the num1 array and it is having further 3 positions. Here I can just copy the elements of num2, that is 2, 3 and 4. So now all the elements are present in num1. The second step can be I can just sort this. Then it will be very easy, right? So here I can just do that 1, 2, 2, 3, 3 and 4. So after sorting, I'll be getting the desired output within the num1 and this can be further returned. So that's very fine. It can be a possible solution. But if you can just look into the complexity of the solution, this will approximately come out to be n log n if you just apply some efficient sorting algorithm, right? So on the basis of this, I can just say that this is a solution, but you cannot call it an optimal solution, right? So we have to further dive deeper into its concepts. So the keyword that we haven't looked upon as of now is the non-decreasing nature of num1 and num2. So let's leverage upon this. In the next solution, what we have proposed is, what about creating a new array for it? So let's go with creating a new array where we'll be actually storing the result. Okay. So let me just draw the spaces for it. So first of all, I have created a new array, then initialize 3 index. Okay. So I am initializing P1 as first index for num1. I am initializing P2 as next index for num2. And for this new array, I'll be keeping account of which index position I need to fill in. So I am having a P index. Okay. So now the third step says compare and arrange. So basically what I'll be doing is I'll be comparing the elements of P1 and P2, and whichever is smaller, I'll be just putting that at its place in this new array. Okay. At pth index. So out of 1 and 2, you can see 1 is smaller. So I'll be targeting 1 and I'll be keeping it here. And then I'll be incrementing P1 since this element is consumed now. So I'll be incrementing P1. Similarly, I'll be incrementing the P pointer. So this is the next position where I need to accommodate the next element. So again, I'll be comparing 2 and 2. Since these are equal, let's say that we are right now giving priority to P1 only in case of equality also. So that's why, and now I'll be again putting 2 here, and then I'll be incrementing P1 further since this is also consumed. Now I'll be comparing 3 and 2. Now since 2 is smaller, so I'll be accommodating this at its place, and I'll be further incrementing P2 and P. Okay. So now again we'll be comparing 3 and 3 since in case of equality here we have given preference to num1. So I'll be accommodating this element and I'll be keeping it here, and further I'll be incrementing it. Now since all the elements of P1 has finished, so that's why I'll just be copying the rest elements of P2 at its position. Now I'm having the complete result in this new array. But as per the question, I need to copy it back to the num1 because this actually will be returned automatically, right? So that's why I'll now be copying all the values of this back, and this is how I'll be now keep storing the result in num1. So now it will be automatically returned, and I am having the correct result at its place. But again, if you can look at this solution, this, yes, it has provided you the solution, but still you are having a drawback of creating a new array, and you have used extra space time complexity of m plus n, right? Can't there be any solution which actually just don't use this extra memory also and just give me a linear time complexity? Then yes, the solution still exists. Now we are going for the third approach, that is the optimal approach. What is the key? Start from back. Okay. Again, I'll be using that 3 indexes approach only, but I'll be using this array as the final for storing my result. So what needs to be done? Say for example, again, I'm initializing P1, I'm initializing P2, but initializing them from the back. So I'm just taking last element of P1, I'm taking last element of P2, and also I'm taking P as the greater element needs to be stored first. So that's why I'm initializing P from the back. So now again compare and arrange. Since we are starting it from the back, so now I have to compare and take the greater element now. Okay, so I'll be comparing 3 and 4. Now since 4 is greater, so what I'll be doing, I'll be putting that 4 at its place now, and I'll be decrementing P for the next accommodation of element, as well as since it is consumed, I'll be decrementing P2. Now again I'll be comparing 3 and 3. Now in this case we are giving preference to num2, otherwise its element will be lost. So that's why I'm now picking 3 here. I'll be overwriting here 3, and since it is consumed, I'll be decrementing P2 as well as P for next element. Now again it will compare 2 and 3. Since 3 is greater now, so now I'll be using that, overwriting it here, and further I'll be decrementing P2 and P. Now if you can have a look, 2 and 2 are equal and we have given preference to num2 in this case. So P2 will be decremented, 2 will be overwritten here, and further you will be having this as next place for P. But now you can see all the elements for num2 has finished. So basically, no need of further carrying over the complete loop. You can just apply a break for this because all the elements have finished for P2, right? For num2 array. The P2 is at index 0. So here we can apply a break and break the loop, and you can see that I am having the complete result stored in num1 itself, which will automatically be returned back. So this is how we can efficiently uh, just derive a solution for this specific case. Now, if you just want to have a look how we can do this in coding, so let's see it. As per the rule, we have to start from the back and we have to initialize 3 pointers. So same is the case. We have taken P1, P2, initialize them as last element for each array, and then I have started a reverse loop. Then this is the edge condition, that is if all the elements for num2 at that is P2 is having an index of less than 0, means all the elements for num2 have finished, then you need to apply a break. So basically this case I have tackled here. Now the next one, otherwise if element of num1 is greater than element of num2, then at pth position or index you can just place num1 element, otherwise you can just place num2 element. So at the end of this loop, it just makes sure that all the elements stored in num1 are sorted in non-decreasing order. So this is what we actually targeted for. So this was an efficient solution for this specific problem. That's all from my side. Thank you for watching. Have a nice day.